presenting an analysis of deep learning models trained on the Dow Jones dataset, and the analysis will include predictions on different indices as well as on stocks of different types like tech stocks, health stocks, and automotive stocks. So I'll be using several models like LSTM, bidirectional LSTM, GRU, GRU hybrid with CNN, LSTM hybrid with CNN, etc. And I will be conducting an analysis of their performance. So I carried out some hyperparameter tuning for the CNN LSTM hybrid, and based on that I developed the model. I also carried out the tuning for the CNN by LSTM model, and here were the results. So on Dow Jones you can clearly see that bidirectional performed the best, followed by the CNN LSTM hybrid, and then the by LSTM CNN hybrid, all for k equal to 10. In general, the general consensus is that performance was best with the bidirectional model, although the CNN LSTM hybrid also performed similarly for several models, for several indices. So now this is the prediction. So what I'm doing in this function is I'm taking the best models, and whatever is the best model, I'm plotting the predictions based on that. So this is the prediction for Dow Jones. It's an error of 190, and you can see average level is around 20,000. So I've got the error under 1%. Now for IXIC, also similar bidirectional, k equal to 10. Similar for GSPC, and for XLK I'm using the CNN LSTM hybrid, as even that gives good performance. And then I have some functions for predicting the best performing model for each stock in a particular sector. So for example, for healthcare stocks, again I carry out the same analysis to find which is the best model for all of them, and we see that bidirectional is the best model for all of them with k equal to 10, and then these are the predictions. So in general, individual stock data is more noisy than data for indices, but we can still see that the error is around 1.5%, error of 4.6 with an average value of 300. Similar for this too, similar error for this too, and for this as well. So now I've got some tech stocks, Intel, Amazon, and Meta, and here the performance is quite similar. Once again we have bidirectional as the best model and value of k as 10, and the predictions are again quite similar. This one has a particularly high error because there is actually a decline in the stock in the long run, about 3% error because of that. This one again has a similar error of 2% or so. I'm using the bidirectional model to predict for all of them. And now for automotive stocks, I'll be using Tesla, General Motors, and Ford for this. And once again we find that the bidirectional is the best model, which is closely followed by the LSTM GRU hybrid in this case, and even the CNN LSTM hybrid performs decently well. Similarly for General Motors, again bidirectional is the best, followed by CNN LSTM hybrid, and for Ford as well, bidirectional is once again the best model, followed by the LSTM GRU hybrid. So we see that the LSTM GRU hybrid actually does quite well for automotive stocks, although bidirectional LSTM is still the best model. And now then I've got the predictions, and the prediction is about the error is very similar, about 3% for 2 to 3% for all of the models. And now for aerospace and defense stocks, I've got Boeing, I've got RTX. Once again we find the errors, and we see that bidirectional again performs the best, closely followed by the CNN LSTM hybrid, then the by LSTM CNN hybrid. Similarly for Boeing, again bidirectional performs the best, followed by the LSTM GRU hybrid this time. And for RTX, again bidirectional performs the best, followed by the by LSTM CNN hybrid, and then the CNN LSTM hybrid. So I've plotted the predictions with errors of around 2% once again. So in conclusion, I would say that the model error is a little bit less on the indices, but it is slightly more for the individual stocks, because individual stocks are more noisy than general stock market indices.